Hey guys, welcome to the second video for determining a function in continuous versus discrete. This section of the video goes over continuous versus discrete. So here we're given two graphs. We have one with a solid line and one with a bunch of points. So the obvious point here, or obvious difference, is that one is solid and the other one has a bunch of different points. So a continuous would be an unbroken graph, and discrete would be isolated points. And the way I was taught in high school was that if I could take my pencil and just draw a straight line through it without having to pick it up, that's continuous. But for the points, I have to literally pick up my pencil in order to draw individual points. So that's discrete. All right, so we're going to have some real world examples. We're going to say whether it's continuous or discrete, and then why. Before I do that, I want to kind of give you a brief overview of what I mean by discrete. So continuous would mean just continues, and you can have bits and pieces and fractions of things. I can cut it up into multiple parts. Discrete means I can have only whole numbers of things. So if I go to Walmart and I want to buy a bag of chips, I can't rip a bag of chips in half and be like, hey, I want to buy half this bag of chips. You have to buy the whole bag. So discrete means you have to have whole parts of something. Same thing with people, right? You can't have parts of people, you can only have whole people. So, number one, the weight of an elevator is dependent on the number of people in it. You always want to see what it's dependent on. So that's why I'm always going to box dependent. What is it dependent on? The number of people. The weight is dependent on the number of people. Well, the number of people, I can't have parts of people. I have to have whole people. So this is going to be discrete. You can't have part of a person. All right, number two, the gallons of gas in your car depends on how long you've been driving. How long? Well, how long means like time. So this would be like how many miles, or how many hours, how many minutes, something like that. Well, time, is that continuous or discrete? Time is continuous. Time is going to continue forever and ever. So this would be continuous problem or continuous statement because time is always continuous. Any problem that depends on time is going to be a continuous problem. All right, number three, I have the amount of money spent depends on the number of candy bars you buy. So it depends on the number of candy bars. You can't go to Walmart and buy half of a candy bar. You can't rip it in half and then ask to buy it. It doesn't work like that. You have to buy a whole amount of a candy bar. So this is going to be discrete. You can't buy part of a candy bar. All right. And then the last example is when making cheese. The weight of cheese depends on the number of gallons used. So when you're at the gas station and you're pumping that gas in and there's numbers telling you how many gallons you're being put into your car, it doesn't say, oh, you can only put 5 gallons or 4 gallons. You put in a bunch of random parts of gallons. So you could have 6.33 gallons, 6.278 gallons. So you can have bits and pieces of gallons. You can have half a gallon, a quarter of a gallon, an 1/18 of a gallon. So gallons can be split up, which means this is continuous because you can have fractions of a gallon. All right. So now we're going to go ahead and start talking about domain and range of discrete data. And then the last page of the notes is over continuous data. So these are all discrete functions because, well, first of all, we don't know if they're functions. We'll find out soon. But remember, a function has only, for every input, only has at most one output. But we're going to go ahead and do domain and range for all of these 4 graphs or 4 representations. We have a table, a mapping diagram, an ordered pairs, and then a actual graph. So these are all discrete because they're all isolated points, right? Like the first one here with the table, we have 5, 2, 6, 3, 7, 4, 8, 6. I could graph all of those. Those are individual points on a graph. Same thing here. I have 3, 6, 2, 7, 4, 7, 4, 10, 7, 5. Those are all separate points. Here, 3 separate points. Here, clearly separate points. All right, so domain is going to be our x values. So when we're listing our x values, we want to list all of our possible x values, but I only have 4 here. So this wouldn't be all real numbers because I don't have all of the numbers for x here. Like I don't have -3 or 1 or 4 for that matter, right? So we're going to list them. And when we list, we draw little curly braces. And so if you're having trouble drawing curly braces, they're kind of like those birds you used to draw, like when you would draw those like sunset photos and you would have like birds flying in the background, you know? So it looks like a bird sort of, but you have an extra like little beak in there. So that's kind of what a curly brace looks like. All right, and we're just going to list our x values, all of our x values. So we have 5, 6, 7, and 8. Okay, and then range is going to be all of our possible y values, or all of the y values we have, which are 2, 3, 4, and 6. And that's literally it. All right, for mapping diagram here, same thing. Domain is our x values, and we're going to list all of them. We have 3, 2, 4, and 7. For our range, we have 5, 6, 7, and 10. No, it doesn't matter the order. If you want to do least to greatest, sure, go ahead. Let me ask you this question. Is this mapping diagram a function? The answer is no, because 4 is mapping to 7, but also mapping to 10. So it's cheating, doesn't work. So let me give you an example on the side here, because I don't have it in the notes. So let's draw a little example, 1, 2, 3. All right, so let me ask you for the domain here. So our domain here, 1 is mapping to something, 2 is mapping to something, and 3 is mapping to something. So I have a domain of 1, 2, 3. My range here, however, is only 5 and 7. And the reason why it's only 5 and 7 is because nothing's being mapped to 9. There is no output of 9 because nothing is outputting it. So our range here would only be 5 and 7. Okay, we have 3 ordered pairs here, but like earlier, domain is x, range is y. So we're going to list all of our possible x values. So these are ordered pairs. Remember, ordered pairs is x comma y. I'll put that on the side so we kind of remember x comma y. So all of our x values is 1, 2, and 6. So if I was asking if this was a function, it would be 1, 2, and 6. And then we have our range, which is our y values, 5, 3, and 12. All right. Moving on, here they're not giving me points, so I have to find them myself. So I'm going to go ahead and find all of these points. So this point down here, what would this be? And so I'm matching it up with the tick marks, because normally you have a graph that has like nice squares for you. This doesn't, so I'm trying to match it up. So this point would be -4, -4. Okay, this point down here would be the point -2, -1. And if you're having trouble identifying what your points are, please let me know. But basically, we're just listing the points as they're plotted. This one's going to be 0, 1. This one's going to be 1, 2. This one's going to be 3, 0. And then this one is going to be 4, 4. So to the right 4 and then up 4. So these are all of my points. Now, remember, domain is your x values, so I'm going to look at all of my x values that I have here, and I'm going to list them with my curly braces. So I have -4, I have -2, and it doesn't matter the order you're listing them in, but I just like to go left to right. Sometimes least to greatest also. I have 0, I have 1, I have 3, whoops, and then I have also 4. All right, so these are all of my possible x values. So they're all the x values that are listed there. Now we're going to go ahead and go and do our range, which are all of our y values. So it's all of the y values of all of your ordered pairs. So -4 would be the first one. -1, 1, 2, 0, and 4. Again, there's no particular order. I just like to do left to right and sometimes least to greatest. All right, on this page, we're going to be determining domain and range for continuous data. So all of this data is continuous because you can take your pencil and draw a solid line through it without picking it up. We just struggle with this a little bit, but I think once you get like through the groove of things, it gets a little bit easier. There are some important notes I would like you to make at the top. So for domain, and just to remind you, that's x values. Domain, okay, we always want to go from our negative to our positive numbers. So domain is x values, and on our x-axis, we have our negative numbers on the left and positive on the right. So you always want to go left to right when we're looking at domain. For range, which is our y values, we're going to start at the negative and go to the positive, which is going to be from the bottom to the top. All right, another thing that I would also like to review is open and closed circles. So when we have a closed circle, our inequality signs are going to have equal to symbols. And if it's an open circle, then we have no equal to symbols. All right, so I think we're ready to begin. So on most of these problems, you have most of them, right? Not all of them. Some of them you have points, and there's like these points. So this line doesn't go on forever and ever because there aren't arrows. There's points there, so it does have a restriction. And when our domain and range has a restriction, we can't just be like, oh yeah, all real numbers, right? We have to tell the person or the piece of paper, whoever's asking, right, what the restriction is. So we're going to find domain first, which is our x values. And you always want to start left to right. So I'm going to start on the left side, and it's really hard for me to kind of show you with my hands because you're only seeing a screen. So if I start at the left, the first x value that I encounter is at -2. So I'm going to list -2 here. And then as I go to the right, what's my farthest right x value? It's going to be at +4. Okay, now I know domain is x values, and I know my x values are in between -2 and 4. Now we have to have inequality signs letting us know, hey, like how is it in between -2 and 4? Well, -2 is less than all of my x values, and also all of them are not less than, they're all greater than -2, but all of my x values are less than 4. So I'm just saying, hey, my x values are between -2 and 4. Yes, your signs do have to face this way because we're going left to right. So as long as you do left to right, you should never have to change your inequality signs the way they're facing. And this makes sense, right? Like if this wasn't here, -2 is less than x. That makes sense because -2 is the smallest of all of these x values. Okay. Then the next part is we have to figure out, do we need equal to symbols? So at -2, right here at this x value, I have an open circle. So I don't have an equal to symbol there. But at x, where x is 4, it's a filled in circle, it's closed. So I do have an equal to symbol there. All right, and that's it for domain. So the first one's always a bit tricky, but you have to get into the groove of things and you kind of get it a little bit more and more. All right, our range is going to be our y values. So we're going to start at the bottom and go to the top because we want to go from negative to positive. Well, the first y value I encounter on my y-axis is at 0. Okay, and as I go to the top, the next y value I encounter is at +4. And again, my y is sandwiched in between those, and my inequality signs will always face that way, as long as I'm going from left to right or top to bottom, or bottom to top, depending on x or y, right? Okay, now let's talk about whether we have closed or open, or equal to or not equal to signs. So at y equals 0, or at y when it is 0, I have a closed circle, which means I do have an equal to there. When y is at 4, it's an open circle, which means I don't have an equal to symbol. So I'm going to leave it as is. So that's my domain and range for number 1. Again, it's a little weird until you get the hang of things. All right, domain is our x values here. Again, start at the left. If I start at the left, the very first x value I encounter is at -3. And as I keep going on and on and on, the next x value to the right, the very, very far right, is going to be +4. And all of my x values are in between that. I'm going to have those inequality signs. Okay, now let's talk about, do I need equal to signs? Well, when x is 3, there's a closed circle, so it equals. And when x is 4, there's also a closed circle, so that's also going to be equal to. All right, now we're going to do our range. We're going to start at the very bottom, and we're going to go to the top. So at the very bottom, the first y value I encounter is -3. And as I keep going up and up and up, the highest y value I see is a 2. All of my y values are in between that, and so my inequality signs are going to look like this. At both y values, I have closed circles, so I'm going to have equal to on both. All right, number 3 is a little bit different. Here we have arrows, and it's also a vertical line, so it's a little bit different because we have a vertical line. Domain is still x, though. So let's look. Let's start at the left. As I go from the left, the first x value I hit is at 4. Well, from the right, it's also 4, right? So it's only 4. My x value is only 4. So if it's only 4, then I'm going to say x equals 4. Okay, for range, well, I have arrows. And do I have a minimum amount? Like, does it just keep going? Yeah, and it just keeps going here. So there is no minimum y value or a lowest y value, and there's no highest y value either. So my y values stretch from all the negatives and all of the positives, which means I have all real numbers for my range. And I kind of want to talk about lines for a second. So lines are solid. Like if it's a solid line, it is made up of a bunch of tiny little points all smushed together, and they make it look like a line. So a line is just a bunch of infinitely amount of points, and all of those points are closed. So a solid line is all of a bunch of points closed together. They're just really tiny and all stuck together. And so yes, right here where I have a red dot, there is a point there. I just don't have to, it just wasn't written at first, but there's still a point there because it's a solid line. And that'll come into play in a little bit. All right, number 4, find our domain here. So let me look at my x-axis. Well, from the left, this arrow just keeps going. So I have an infinite amount of negative numbers that it hits. Same thing on the positive side. So my domain for my x values is going to be all real numbers. For my range, which is my y values, if I start at the bottom and I start going up and up and up, the first y value I hit is 2. And it's the only y value I hit. So it's going to be y equals 2. So it's like the opposite of that third problem. So sorry if I'm talking really fast, but always feel free to, slow down the video. All right, I'm just trying to make the video not too long. Number 5, domain is x. So let's start at the left. So starting at the left, the very first left value I encounter, or x value I encounter, is at -5. Now, this is a problem that gets a lot of people, right? So I say, okay, keep moving to the right. What's the farthest right value you see? And a lot of people want to say this point right here at +2. However, if you're saying that this is the farthest right that you have, you're forgetting about the rest of this graph over here. So 2 is not the farthest x value that I have. It is actually at this point, which is 4. And yes, there's a point there. It's just not filled in, but it is closed because it's on a line, right? A line is made up of an infinite amount of closed points, unless it specifically says, hey, like I have an open point in the middle of my line, right? So this would be an open point, but I don't have that here. Okay, domain is your x values, and so you know that you're going to have your inequalities facing this way because it's restricted between -5 and 4. Now at -5, my x values, at -5, the x value is a closed circle, so I'm going to have an equal to. And at +4, it is a closed circle, even though it's just a line, so it's going to be equal to there as well. Ranges are y values, so we're going to start at the very bottom. The very first y value I encounter from the bottom is at -4. And then if I go all the way to the top, the next y value, or not the next, but the highest y value is 3. My y values are in between those. At y equals -4, I have a closed circle, so I have an equal to. At y equals 3, I have a closed circle, so that's also equal to. All right, moving on. Last one. Number 6. So this was a little bit different, right? Now we have a close, and then there's an arrow on the other side. So this is the first time we've kind of seen something like this. So we're still going to treat it the same. So domain is x. So we're going to start. Starting from the left, what's the first x value I hit? Well, the first x value I hit is at -3, not +3. And then as I keep going, it just keeps going and going and going. So there is no restriction that way. So yes, there's a restriction, but there isn't going to be anything on this side of the x. It's just nothing there. So let's look. Is -3 less than all of my x values or greater than all of my x values? It's less than, right? Like -3 is the smallest, and then it gets bigger and bigger. So that means that we have -3 is less than x, and then it's also equal to because it's a closed circle there. So here I just have one variable with one inequality instead of 2 inequalities, or inequality signs. All right, our range is going to be all of our y values, so we're going to start at the bottom and go to the top. At the very bottom, I have 0. Right, so I have 0 here. So 0 is our lowest y value, and as I keep going up and up and up, well, this arrow is going to continue to increase and increase and increase. So my y values just continue to get more positive and positive. So I only have a restriction on one part of my graph, not the other part. So this is going to be kind of the same thing as our domain. Okay, well, 0, is that less than all of my y values or greater than all of my y values? It's less than. It's the smallest of all of my y values. And at 0, it is a closed circle, so I do have an equal to sign. All right, so I did go through that a bit fast, but the more you go through it, the better you get the hang of it. So please feel free to ask any questions during my tutorial times.